Hello everyone. Today we will present air pollution associated with waste to energy. My name is Xinjie Wei and let me introduce my group. Mali, Asha, Zhechen, and Carline. We will introduce what is waste to energy and what is the team case study. Then we will mention the major pollutions and health impacts. Finally, how these pollutants are regulated and their control technology. Waste to energy is a process of combustion residential waste, which include food waste, plastics, paper, gas, under very high temperature and generates steam to drive the turbine and generate electricity. So why we use waste to energy? Waste to energy is profitable. Besides, the environmental impacts is found to be much less than fossil fuels. So the benefits of waste to energy include cheaper fuel, federal incentive, environment protective, such as saving landfill and laser emission. Why we care about emissions? According to the World Health Organization reports, over 7 million people die every year due to the air pollution. Air pollution such as NOx, sulfur dioxide, PM, will also be generated during the waste combustion period. These pollutions will have a healthy impact, so engineers need to use control technology to eliminate the emission. Team case study is Covanta Energy Corporation. It's a waste-to-energy plant that changed to the NSW2 power. Covanta currently operates over 40 older waste-to-energy facilities around the world. There are 6 in Florida. Our tour was at Covanta Lake County Corporation. It's located in Oakham Park, Florida. This plant began commercially operating in March 1991. The facility processed a total of 528 pounds per day of solid waste, while generating up to 14.5 megawatts of renewable energy. Next, let's watch a video of the waste-to-energy process. Non-hazardous residential and commercial waste is delivered to a facility where it is combusted in a specialized chamber, creating steam that drives the turbine and makes electricity to power our homes and business. Emission control system cool, collect, and clean combustion gases. All this is continuously monitored to comply with state and federal standards. At the end of the process, metals like steam are recovered for recycling, and the remaining material are beneficially reused or disposed of in a landfill.
Hi, now let's discuss the major pollutants and its impacts emitted in waste to energy process. The first is the oxides of nitrogen. The NOx represents mainly the nitrogen dioxide and nitrogen monoxide, and that is generated due to 2 ways. One is the thermal NOx due to the combustion at a very high temperature, and the fuel NOx due to presence of nitrogen in the fuel. And as you know, that the NOx is the precursor of ozone, and the impacts of ozone applies to NOx as well. The NOx primarily affects the respiratory organs, precisely causing asthma and bronchitis in children. Secondly, let's see about the carbon monoxide. It is one of the major pollutants in the global context. It is produced due to incomplete combustion and presence of carbon in our fuel, and carbon monoxide causes damage to hemoglobin, thus high blood consuming organs such as brain, heart. This gets damaged and it results in impaired concentration, slow reflexes, and confusion. Coming to next, these are the acid gases which are very severe in impact because this causes this increases the acidity of freshwater lakes. This causes acid rain which impacts the historic monuments, and this affects the coral reefs also. Now let's go to the next slide. Particulate matter. These are the suspended particles in air. They can be organic or inorganic as well. The majority of health impacts due to air pollution is attributed to particulate matter. These are characterized by aerodynamic diameter and their ability to settle in the part of our respiratory organs, say nostrils or deep into our lungs. They majorly cause respiratory, cerebrovascular, and cardiovascular diseases and of concern to very young children. Next is dioxins and furans. These are organic compounds and are generated due to incomplete combustion and presence of chlorine and in our waste. Dioxins and furan mixes with air and get into the plants and in turn into our food chain. This process is called biomagnification, and it impacts our nervous system, decreases the nerve conduction velocity, and impairs the mental development in children. It is also found to damage liver and as a result increase in the levels of certain enzymes in the blood. Heavy metals. The heavy metals generated in waste to energy process are lead, cadmium, and mercury. These are generated in trace amounts. These are generated mainly from electronic waste. Although these are generated in trace amounts, their health impacts are very serious and it's very expensive to treat. Of particular, the health impacts of heavy metals are sleep disorder, blood pressure, blood vision, and a kidney malfunction. These are the major pollutants and health impacts associated with waste to energy process. Now, let's see the regulations for these pollutants.
In general, air pollution regulated under the Clean Air Act that was enacted in 1977 and 1990. This law authorized EPA to establish the national efficient air quality standard to protect the public health and public welfare, and also to regulate the emission of the hazard air pollutants. Under Section 111 of the Clean Air Act, EPA developed a technology-based standard called the New Source Performance Standard, which applied to a specific category of stationary source. In our case, is solid combustion waste or waste to energy as a new stationary source. These standards are found in 40 CFR 60. From the NOx and NESHAP, the primary issues that need to be controlled for the waste to energy facilities are metals, which include the PM, cadmium, mercury, leads, acids, gases, which is sulfur dioxide and hydrogen chloride, organic, which is dioxin, nitrogen oxide. Even though CO is not considered as a primary pollutant, but is also regulated just as protective. So we have to have regulations for that. These emissions are from the combustion process regulated based on the maximum achievable control technology standards. Next, we will talk about the regulation at the state level and what are the maximum concentration for each pollutant. At the state level, they are emission regulated by Florida Department of Environmental Protections. In general, the state regulation is more strict than EPA. However, in Florida, the regulation is the same. The rollout could be found in the FAC 62296 emission limit standards. This table shows the concentration limit that should be followed by the facility. Again, this concentration is based on the maximum achievable control technology. So, how we meet the regulation standard? Next, Asha and Zichan will talk about the control technology for the pollutants.
Okay, so first pollutant we want to talk about is carbon monoxide. As Madi mentioned before, this pollutant is not considered as a primary, but we need to consider that as a protective. In our case study, Covanta, carbon monoxide is reduced by excess air to make complete combustion. So during the combustion, the ratio of the air is at a little bit more than the stoichiometric. However, other alternative methods can also be used to control the carbon monoxide in general, like adding secondary burner or the catalysis, and but in catalysis is not a good alternative way because that in our case the temperature of the operating is much more higher. So combustion will be the best control technology. Okay, let's move to the first major source of pollutant, NOx. Covanta use selective non-catalytic reduction, which use ammonia to reducing the NOx, and we can show as the formula ammonia reaction with the nitrogen monoxide together with oxygen will form the nitrogen gas and water. So this reaction should be controlled exactly between 800 to 1000 degrees Celsius, and the higher temperature will oxidate ammonia to nitrogen monoxide, which we don't want. So other technologies can also be used, such as an SCR, selective catalytic reduction, and stage field conversion, also known as the reburning and the hybrid technology. In waste-to-energy, the temperature of the downstream of the boiler is much higher than SCR. So here we will not use the other choice because the catalyst will be destroyed at a very high temperature. As for stage field combustion and methanol rebrand, both of them need extra device to remove NOx, which has much higher cost. So the best way to control the pollutant is by hybrid technology, which is a combination of two above technology. For waste-to-energy, reburning and selective non-catalytic reduction is main two technology. Sulfur dioxide and hydrogen chloride gases are second major source of air pollution in waste-to-energy. The control technology that used in Covanta is spray-dry scrubbing. In this picture, the limestone slurry is injected into the spray-dry absorber through the atomizer at the top of the absorber tower. Atomizer producing smaller droplets for increased absorption of acid gas, thereby reducing the pollutant emission. Other technologies available are wet lime scrubbing and dry lime scrubbing. Wet lime scrubbing has handling the disposal are main issue associated along. Although dry scrubbing also follow this similar approach to spray dry, the efficiency is slightly lower.
Toxic organic compounds such as dioxins and furans and metals such as cadmium, mercury, and lead are controlled in Covanta by using powder activated carbon that follows the adsorption technique. PAC can be removed up to 90% of dioxin and furans. Covanta uses dry abatement system as opposed to semi-wet or dry and wet abatement system. The reason being, it is of high temperature injection of PAC for lower temperatures of semi-wet or semi-dry, which is usually used. The pollutants along with PM are collected in the filter baghouse and disposed of. The technology used at Covanta for particulate matter is fabric filter baghouse operating on pulse jet. The technique helps to remove particulate matter PM, including fly ash and activated carbon, which is being injected along to absorb the toxic organics. A baghouse comprises of hundreds of filter bags operating at a temperature around 120 degrees Celsius with high efficiency removal. The particles will be collected and then disposed of to landfill. Other alternative devices that can be used are cyclones and electrostatic precipitator. However, in Covanta, pulse jet bag houses is used as it is cheaper. In conclusion, the study of major pollutants and the project research, it was evident that energy recovery from waste is a favorable option over landfill disposal. Its added advantage over fossil fuel combustion, and since the environmental impacts and the cost of fuel are less. The emission standard for waste to energy units is a new source performance standard regulated by EPA. From these, the major pollutants to be controlled are nitrogen oxide, carbon monoxide, lead, mercury, cadmium, particulate matter, dioxins, furans. The adoption of technology is to meet the criteria of regulatory standards set by federal and state. For more information, visit our website at this link and feel free to post your comments. Thank you for listening.